Welcome in the course of Heat Transfer. I am Mehul Pujara, faculty in Department of Mechanical Engineering at B.H. Gardi College of Engineering and Technology, India. Today I would like to discuss about heat conduction in composite wall. Learning objectives are to understand concept of thermal resistance, to understand heat transfer analogy to electrical current flow, conduction resistance and thermal circuit. These are the two key concepts covered in this presentation. Heat conduction in plane wall. In previous presentation we discussed about Fourier's law of heat conduction. The Fourier's law of heat conduction, written in the form of equation, that rate of heat transfer by conduction is minus Ka dt over dx. K represents thermal conductivity of the material, A area normal to the direction of heat transfer, dt over dx represents temperature gradient, where dt is difference of temperature, dx thickness of the plane wall. If suppose the thickness of the plane wall is L, so if we integrate the above equation in the range of 0 to L, equation can be rewrite the rate of heat transfer by conduction in a plane wall is equal to Ka T1 minus T2 over L. Thermal resistance concept. What is conduction resistance? Equation number 2. We just rearrange this equation number 2 in the form of rate of heat transfer by conduction in wall is equal to T1 minus T2 over R wall, where R wall is conduction resistance. R wall is equal to L over K into A. If we look at the equation number 2, it is rearranged in the form of T1 minus T2 over R, where R is L over Ka. L thickness of the wall, K thermal conductivity of the material, A area normal to the direction of heat transfer. Let us look at the heat transfer analogy to electric current flow. As we know that the voltage difference V1 minus V2 is responsible for the flow of current. Similar way, if we draw the thermal circuit, the difference of temperature is responsible for the heat transfer. So we can say that the rate of heat transfer is similar to electric current in electric circuit. Thermal resistance is similar to electrical resistance, and temperature difference is similar to voltage difference. Let us look at the heat conduction in composite wall. Composite wall, the wall which is made up of more than one material. If you look at this figure, the wall is made up of two different material having thermal conductivity K1 and K2. If suppose thickness of material 1 is L1 and thickness of material 2 is L2, area is same for both the material. One side is maintained at temperature T1, another side is maintained at temperature T2. Let us assume that T1 is greater than T2, and because of that, the rate of heat transfer is take place in the direction of decreasing temperature. For composite wall, we can write thermal resistance for composite wall is equal to L1 over K1 into A, thermal resistance for wall 1, plus L2 over K2 into A, where L1 represents thickness of material 1 L2 represents thickness of material 2, K1 thermal conductivity of material 1, K2 thermal conductivity of material 2. So we observe the change in the value of RTH. Otherwise, the relation we can write R Q dot conduction, the rate of heat transfer by conduction, is equal to T1 minus T2 over R1. We observe that the change in value of R1, it is L1 over K1 into A plus L2 over K2 into A. Right? And mass transfer by units and essential, that reference book we have utilized to prepare this presentation.